Okay, so today's notes are on adding and subtracting rational expressions, and our content objective is to do just that. Our language objective is to use the correct terminology to explain how to do that. So let's jump in with reviewing generally how to add and subtract fractions. So first thing I want to note, to add and subtract fractions, or generally rational expressions, you need a common denominator. So just a reminder, you do not need a common denominator to multiply or divide, but you definitely do to add and subtract. So adding and subtracting, you need a common denominator. Multiplying and dividing, you do not. So let's do a quick review. I want us to add 1 over 6 plus 2 over 3. And some of you may be able to do this really quickly without doing any math on the paper, but I want to review the process we go through to do this so that when we apply it to more complicated looking expressions, it's not so confusing. So the first thing I want us to do is find factors of each denominator. So again, the factors of 6, so if I make a factor tree of 6, it's just 2 times 3. There aren't any other prime factors of 6, and there aren't any factors of 3, so it's just 3, or 3 times 1. So if you realize, or if you notice, what the denominator here is missing is a 2. So you recognize what the other denominator is missing, so what is not similar about them now, so that I can then make it similar. So the second step is going to be multiply fractions by missing missing is not the correct or the exact technical vocab word, by the missing factor over itself. And what I mean by that is, like I said, since 3 doesn't have or is missing the 2 to be the same as that denominator, I'm going to multiply it by 2 over 2, or that value over itself. So when I do that, I now have 1 over 2 times 3 plus 2 times 2 is 4 over 3 times 2, or 2 times 3, which is the same thing, which is just 1 over 6 plus 4 over 6. And then my last step, I'm going to add the numerators only. So again, you don't add denominators or subtract denominators when you're adding and subtracting fractions, only the numerators. So this just becomes 5 sixths. I have 1 6 plus 4 6, which is 5 sixths. All right, so I'm going to continue on to practice this with a more complicated rational expression. So to make sure I have plenty of room, I'm going to flip the page. So bear with me. The example I want us to do together is adding x over x minus 1 plus 2x minus 1 over x squared minus 3x plus 2. So first thing, I'm going to do the same thing I did with our simple numeric fractions. I'm going to find factors of each denominator. So I'm finding the factors. If I look at the first fraction, I have x over x minus 1. I can't factor x minus 1. That is a linear factor itself, so that's going to stay just as it is. And then I have plus 2x minus 1 over, and now this denominator can be factored, so I'm finding factors of 2 that add to negative 3. Factors of 2 that add to negative 3 would have to both be negative, so it'd be x minus 1 times x minus 2. So again, negative 2 times negative 2 gives me positive 2, but they add to negative 3, so that works out just fine. So then I'm going to multiply by the missing value again. In this case, missing expression or value over, again, I'm doing missing in quotes, itself. So if I look here, there's already an x minus 1 in each of these denominators, so that's already a common component in both of them, or a common factor in both denominators. So the only one that's missing in this fraction is the x minus 2. So since this is missing x minus 2, I'm going to multiply this fraction, x over x minus 1, times x minus 2 over x minus 2. So I'm going to multiply just that fraction by this expression over itself, just like we did with the last one. And then this fraction is going to stay exactly as it was, since it already has both the components it needs in the denominator. So then I'm going to now write this as one fraction. And a reminder, when we're adding and subtracting fractions, we do not add and subtract the denominators. So my numerator becomes x times x minus 2 plus 2x minus 1. So I'm adding the numerators, but then the denominators, I'm just going to write the common denominator we have as the denominator. I'm not adding or subtracting them. I'm just taking what I've decided is what I've made as my common denominator and writing it in the bottom. All right, now I'm going to simplify the numerator. So sorry about that. So this becomes x squared minus 2x plus 2x minus 1 all over x minus 1, x minus 2. And then those middle terms are going to cancel. So negative 2 plus positive 2x plus positive 2x is going to be x squared minus 1 over x minus 1, x minus 2. So now I'm going to factor the numerator. And continue simplifying like we practiced last class. So I have x, since this is the difference of squares again, x squared minus 1, they're both perfect squares, so it factors to the conjugates, x plus 1, x minus 1, over x minus 1, x minus 2. The x minus 1s can be canceled out. So that's step 7 is simplify. And my final expression is going to be x plus 1 over x minus 2. But as we practiced last time, we always have to note the values of x that make the original expression undefined. So for x does not equal, if I had plugged in 1 originally, that would have given me 0 in the denominator, or if I plugged in 2. So it's for when x does not equal 1 or 2. And that is my answer. All right, write down questions on that. I'm going to do a couple more examples, not in as much detail with the steps written this way, but some abbreviated steps. But I'm going to do another example right now with adding. So I'm going to flip the page. Let me go over it now. So I'm going to title it a quick check if you want to try it on your own. If you're not feeling ready to do that yet, I'm going to go over it in just a second. So we're adding this. So my first step is to factor the denominators. So I have x plus 1 over x minus 1 plus negative 2 over x times x minus 1. So I factored out the denominator, or the x in the denominator on that one. So multiply by missing value. So I'm going to multiply this expression by x over x. And I'm going to write as one fraction. So I have x times x plus 1 minus 2 or plus negative 2 over x times x minus 1. So that's my new fraction. And then I'm just going to write simplify, and I'm going to do several steps in the simplification process. So I have x squared plus x minus 2 over x times x minus 1. And then I'm going to factor this. So factors of negative 2 that add to positive 1 are positive 2 and negative 1. Those are going to cancel. So I'm left with x plus 2 over x. For I'm going to write finalize. So x cannot equal 0, x cannot equal 1, because those would both make my original equation undefined, so that would be my answer. So x plus 2 over x for when x does not equal 0 or x does not equal 1. I'm going to do one last example with subtracting, and again, I'm not going to write all the steps in detail because it's pretty much the same process except for the numerators would be subtracted. So the hard part is finding the common denominator, but just so I have plenty of space for this, all right. Subtract x plus 2 over x squared minus 2x minus x plus 2 over 2x minus 4. So I'm going to factor the denominators again. So I have x plus 2 in the numerator over, I'm going to factor out the x, which is the common factor in that first denominator, so x minus 2 minus x plus 2 over 2 factors out of that second one, x minus 2. So again, these both already have x minus 2, but each of them are missing one of the terms. So this one's missing an x, this one's missing a 2. So I'm going to multiply by the missing values. So this becomes 2 over 2 times x plus 2 over x times x minus 2 minus x plus 2 over 2x minus 2 times x over x. So again, this one I multiplied by 2 over 2, this one I multiplied by x over x. And I'm going to now write as one fraction. So again, this one was x over x, this one was 2 over 2. So this becomes 2x plus 2 minus x times x plus 2 all over 2x times x minus 2. So again, 2x times x minus 2 is my new common denominator. I write that as 1. I'm now going to simplify, and I'm again not going to write all the little steps of this process because we practiced this last time, but this becomes 2x plus 4, because I distribute that 2, minus x squared minus 2x. And then I'm going to combine the 2x's are going to cancel, and I have, this is still over 2x, x minus 2. When I simplify things, I end up with x squared plus 4 over 2x times x minus 2. I never want to lead with a negative x value, so I'm going to factor out the negative. So I'm left with x squared minus 4 over 2x times x minus 2. So again, you never want to have a leading negative x value, so you're going to factor that out. And now I recognize that it's the difference of squares. So 4 and x squared are both perfect squares, so it becomes x minus 2, x plus 2, because it factors to the conjugates, over 2x times x minus 2. X minus 2's can cancel, and I'm left with negative x plus 2 over 2x. For x does not equal, it can't equal 0, and x does not equal 2. So I go back to this original expression, x cannot equal 0 or negative 2, because that would make my values undefined. So my last step is to finalize. And that is it. All right, so it's a plus. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.